Welcome to the wonderful world of complex numbers here in section 4.8. Complex numbers, otherwise known as imaginary numbers. Well, I shouldn't say that. Complex numbers consist of a real number and an imaginary number. So the new part today is imaginary numbers. We want to be able to work with those imaginary numbers, and we're going to come up with some solutions for quadratics that are actually imaginary and leave them in complex form. So when do you get an imaginary number? Well, when you square root a negative. If you put square root of negative 3 in your calculator, it'd say error. You can't square root a negative because the opposite of square rooting is squaring, and it's like saying this. We want something squared to be negative 3. Well, you couldn't square something and get negative 3. It's something times itself. It's always going to be positive. So you would, up till today, say, hey, you can't do anything with that. You'd leave it square root of negative 3, say no solution. Well, what if I said square root of negative 3 squared? Now, if you put that in your calculator, apparently it'll still say error because you're probably in the real number mode. But if you actually switch it over to complex mode, it'll give you an answer. And that answer would be square root of negative 3 times square root of negative 3. Well, you're multiplying two square roots there, so they're just going to go away and you're going to be left with what's inside. It's square root 3. We've done all kinds of problems where you had to do square root 7 times square root 7. Say, well, that's just 7. You get the number inside. It's the same concept here. So what got introduced was, hey, we might have a problem where we get a square root of a negative and we're stuck. But if we pretend that we're not stuck and keep going, you might end up in real number world here. If you, in fact, end up squaring it. So someone just said, you know what, let's say I is the same as the square root of negative 1. So now from any time on I see negative 1 in a root, I'm just going to disregard the negative, I'm going to get rid of it, and put an I out front. So here's some examples. I've got square root of negative 36. Well, there's a negative in there. I can bring it down like this if that made you feel better, I suppose. I can put negative 1 inside the root times 36 inside the root. But all you really need to do is say, hey, there's a negative outside, so I'm going to put an I. And the square root of 36 is 6. Well, don't leave it I6. It's just like, you wouldn't leave x6. You'd put 6x instead of x6. So the answer is 6i. So example 2, I've got a negative inside, so I'm just going to put an I for that. And I'm going to break down the square root of 200, just like we've been doing. Perfect square that goes into 200 is 100. So that's 10. Root 2, and in your book you're going to get that I squeezed right in the middle here, just so that I doesn't look like it's under the root. The I isn't under the root, it's outside. So that's why I put it in between the 10 and the root symbol there. Might come up with some quadratic equations to solve that end up with negatives. Here you'd subtract 8. Divide by 2, and you get x squared equals negative 2. Well, what's your next step? It's to square both sides, square root both sides. And as soon as you square root, please remember to not be that guy who forgets plus or minus. So you have x equals plus or minus. There's a negative, so I'm going to put an I down. And I can't simplify root 2, so we're just going to leave it root 2. And that'd be the proper way to put it, with the I in front of the root 2 again, so you make sure the I doesn't look like it's under the root. If you did this, someone might think, oh, is it under the root? And that's what you want to avoid, so we'll put that in front. So these problems are very similar to what we've already done. It's just end up with imaginary. So example 4, we got to get the square alone, so we're going to subtract 4. We're going to divide by 3. Then we square root. We square root, we get x minus 2 equals plus or minus square root of negative 8. So I get x minus 2 equals plus or minus. Well, there's going to be an I because there's a negative, but then you also have to break down the 8. So how do you break down square root of 8? It'd be square root of 4, square root of 2. That'd be 2 root 2. So how are we going to write that? We're going to put the 2 in front of the I and the root 2 after the I. We're not quite done yet because x isn't alone. We need to move the 2 over and just put that in front as positive 2 and then put your plus or minus 2i root 2 that we had from above. There's your answer. I'm gonna skip the I cubed, I fourth. That's kind of something I like to do within class. But I squared is important. That's very, very, very important. I is the square root of -1, and then the beautiful thing is if you square that, it just gets rid of the root. So I squared is -1. That is huge. Anytime you see I squared from here on out, you're going to put -1. We're back in real numbers. Got some simplifying problems here next. The first one is just a subtraction problem, so there's really nothing new here. This would be no different than if I had x's or a's or any other variable instead of i's. You're just doing the same work. So when you subtract, hopefully you've been taught to distribute the negative, so that becomes a -8 and a +3i. Then you add the numbers, the real numbers, and get 2. Now the only difference on these is normally you'd put the number with the variable in front, in your final answer, like mx plus b form, 2x plus 3. Well, here you need to have the I at the end. So that's something to note, that we want things in complex form. And when I say complex form, the standard form of that is a plus bi, where a is the real number, and then this is your imaginary number here. So this would be 2 for a real number, and then if I put the imaginaries together, I get 7i, and that's all she wrote. Example 6. Here we got to do a little simplifying. 4i squared is -4. Why is it -4? Because 4i squared is 4 times -1. I squared is -1. Anytime you see an I squared, put -1 down there. All you really need to do is switch the sign of the number in front, the coefficient. So here I have +4, it became -4. I squared went away. And I've got minus, what's the square root of -36? That's 6i. Plus, and I got 12 minus, what's the square root of -81? That's 9i. This is an adding problem, so really there's not much to it. You just drop the parentheses, add the real numbers and get 8, add the imaginary numbers and get -15i. That's in standard form. You have your real number first, imaginary second. All right, now we got to do a little work here. We've got a binomial times a binomial, but we're actually multiplying conjugates here, so you should know there's no middle term. This is simply going to be 5 times 5, 25, and then 3i times -3i, which is -9i squared. The middles would cancel out. If you did 5 times -3i, you get -15i. And if you did 3i times 5, you get +15i. Those cancel. You want to recognize that if you're multiplying conjugates, okay, that the middles will cancel. That'll save you some time. So those would go away anyways. You'd be left with 25 minus 9i squared, which is the same as 25 plus 9. Minus 9i squared is just +9, because you're taking that -9 times -1. So then your final answer is actually a real number, 34. That's kind of cool, isn't it? Example 8, we don't have conjugates, so here you're actually going to FOIL it out. 10 times 4 is 40. 10 times 3i is 30i. Careful here, that's a -2i. -2i times 4 is -8i. -2i times 3i is -6i squared. I times I is I squared. Let's simplify what we can here. 40. Those go together to make 22i. This right here turns into +6. -6i squared is just a +6. The I squared goes away. And then I can put the 40 and 6 together to get a real number of 46. an imaginary term of 22i. Okay, solving. Well, what do we know to do right now? At this point, this year we haven't done any quadratic formula. We've completed the square, so we'll complete the square on number 9 here. Otherwise, you could use the quadratic, but this year we're working on quadratic after the fact. So complete the square. X squared and x are alone, so we're going to make this an x squared term by dividing by 2 first. I left myself some room here so that I could put a plus something here because I need to add both sides. And what is that something? Well, it'll be x plus 5/2 divided by 2 is 5/4. So this top trinomial that we're constructing needs to factor into x plus 5/4 squared because 5/2 times a half is 5/4. Now if you square 5/4, that's what goes up here. If I square the 5/4, I get 25 over 16. 25 over 16. I need to add this side over here. 5 times 16 is negative 80. So this right here is like negative 80 over 16. I just changed it. 80 divided by 16 is 5. So negative 80 divided by 16 is negative 5. 25 plus negative 80 is negative 55 over 16. At this point, I need to square root both sides, and if I do that, I get x plus 5/4 equals, I'm not going to be that guy, plus or minus. There's a negative, so I need to put an I, square root 55 over, square root of 16 is just 4. Okay, so I square rooted this whole thing right here. And I square root of the 55, which I can't break down, but the square root of 16 is just 4. And then now I need to bring over the 5/4 by subtracting it. And this is a little bit different. Instead of putting the I in front of the root, to be in that A plus BI form, we should actually just go ahead and put that I at the end. Okay, so just kind of ticky-tack, but that's what we're looking for. Write it as 2 separate fractions and put the I at the end. That's complex form, A plus BI form. Oh, awesome screen. Here we go. Okay, this guy. Now, just like when we did roots in the denominator is bad, i's in the denominator is bad. So how do we get rid of i's in the denominator? Same as we get roots. We're going to multiply top and bottom by the same thing. And what it'll do, get rid of it here, is just simply an I. Make sure you distribute the I on top. So I'm going to bring it down. But I'm saying distribute that. So you'd have 5i minus 3i squared. And then you'd have 4i squared on the bottom. Now you got to change your I squareds, make them negative 1s, or just change the number. So it'd be 5i. Instead of minus 3i squared, that's just plus 3. And instead of 4i squared, that's negative 4. Now this is a pretty good answer, but we're going to make it a great answer. We're going to put it in that A plus BI form. To do that, I'm going to rearrange the top so it's 3 plus 5i. Put the real number first. And then I'm just going to divide them each by negative 4. So it'll be negative 3/4, excuse me, plus negative 5/4, and then put the I to the side. If you had minus 5/4 I, I'd be fine with that as well. But 3 over negative 4 is negative 3/4. 5i over negative 4 is negative 5/4 with an I to the side. This one down here is pretty tricky. You can't just multiply top and bottom by I. That won't get it done. You actually have to multiply by conjugates on these. Multiply. Let's see. Let's put this in a better spot. Multiply by conjugates. When you have a binomial in the denominator, you got to multiply top and bottom by conjugates. What's the conjugate of 3 minus I? 3 plus I. Okay, so I need to do 2 plus I over 3 minus I times 3 plus I over 3 plus I. You got a FOIL, top, and bottom. Pretty involved. On the top, I'd have 2 times 3 is 6. 2 times I is 2I. I'd have I times 3 is 3I. And I times I is I squared. On the bottom, I'd have 3 times 3 is 9. And then the middles are going to cancel out. You're going to have 3I and negative 3I. So I don't need to worry about that. All I need to worry about is this being negative I squared. Now I need to simplify the top and the bottom. And if I do that, what do I get on top? I get 6 plus 5I minus 1. I squared is negative 1. On the bottom, I get 9 plus 1. I squared is negative 1. So if I put a negative 1 right here, you're going to have 2 negatives, so it's plus 1. Now I have 5 plus 5I over 10. Ding dong dang it, keeps moving on me. And I'm going to change that into 5 over 10 plus 5 over 10I. Divide them both by 10. That's not quite done because we would never leave 5 over 10 as an answer. You've got to reduce those. So our final answer would be 1 over 2 plus 1 over 2I. Kind of a long problem. Running out of time, don't know if I'm going to make it on this last one here. Let's see what we can do. It's a little bit better because we don't have a binomial at the top. We're going to multiply top and bottom by 2 plus 5I, because that's the, 2 minus 5I. I didn't see the plus, I thought, so I was minus for some reason. So 2 minus 5I, 2 minus 5I. Distribute the top, you get negative 12I. Plus 30I squared. On the bottom, you'd have 4 minus 25I squared. The middles would cancel. The 10I and negative 10I would cancel. Let's simplify the I squareds. I'd have negative 12I minus 30 on top, plus 30I squared minus 30. And on the bottom, I'd have 4 plus 25, negative 25I squareds plus 25. I'm going to rearrange the top so the real number is in front. So it would be negative 30 minus 12I, and the bottom would be positive 29. I'm going to split it up. Negative 30 over 29 is my real number, and I could put plus, negative, or just minus, either way. 12 over 29 is my imaginary number. No reducing to do on this one because 29 is prime, so nothing goes into both the 30, 29 or the 12, 29, unlike the last problem. That'll do it for the examples today. Thanks for watching. Have a great day.